In this second video, we're going to cover how do you name compounds when a metal is bonded to a non-metal. So I would say this is our second topic. So metal to non-metal. So let's start with going from formula to name. So suppose we've got this compound, and we've got okay. The first thing you do is name the metal. So in this case, it's potassium. K is potassium. Then name the nonmetal, and then change the ending to IDE. So it'd be potassium chlorine, but change the ending to IDE, so the compound would be called potassium chloride. Okay? Let's try another one. How about this one? So name the metal. The metal always comes first. The nonmetal always comes second. So name the metal. Ba is barium. Name the nonmetal, the nitrogen. And then change the ending to IDE. Barium nitride. Alright. How about going the other way? Going from formula to name. Name to formula. So let's try aluminum sulfide. So the first thing you do is write the symbols. So the symbol for aluminum is Al, the symbol of sulfur is S. Then you write the charges. Since aluminum is in the +3 column, it's a +3, and since sulfur is in the -2 column, it's a -2. Or you can always look up their charges on Appendix A, but it's a lot easier if you go and you look up the charges from the periodic table. So the third thing you do is you crisscross the charges to balance it. So I take the 2, move it there. I don't bring the negative sign over, I just bring the 2 there. And then I bring the 3 over there. So it becomes Al2S3. The bottom number means how many atoms of sulfur you have. So the subscript means how many atoms you have. The superscript means the charge on it. Essentially what you're trying to do is you're trying to balance the charge out to 0. So I've got 2 aluminums, each with a 3+, and I have 3 sulfurs, each with a 2-. So I have 6 positive charges and 6 negative charges, so that whole thing balances out to 0. So that's essentially what you're doing by the crisscross. Okay? So let's try, and I forgot rule number 4, reduce subscripts if possible. So let me do another one that shows you what I mean by number 4. Suppose we were doing a little trouble here. I gotta come back out, come back in. All right. Suppose I was doing this one. Calcium sulfide. Okay. So I'd write the symbols. Calcium, sulfur. Write the charges. +2, 2 minus. Crisscross. Take that 2, put it there. Take that 2, put it there. Well, can I reduce the 2 and the 2? The answer is yes. So I wouldn't say Ca2S2. This 2 goes into that 2. So I would reduce it to just CAS. Okay? I seem unable to advance here. Something's causing me trouble. Shoot. I can't scroll down for some reason. There we go. Alright, sorry about that. Okay, how about we have this one? Let's do, let's see. Lithium phosphide. Okay, so lithium is Li, phosphorus is P. This is a 1 plus, this is the 3 minus. So I crisscross, the 3 goes down there, the 1 goes over there. Now what I should do is when I'm done balancing, I should erase my charges. And if there's a subscript that's a number 1, I should erase it. So that my final answer would be Li3P. Okay, that's the correct way of doing it. If you don't erase your charges, I'm not going to take off points, but you should be erasing your charges. Alright, but now there are some exceptions. There are some elements that can have more than one charge. The fancy name is multivalence. But here are the elements that have more than one charge. There might be 1 or 2 that I missed, but these are the most common ones. So, iron can be a 3 plus, or iron can be a 2 plus. Copper can be a 2 plus, copper can be a 1 plus. Lead can be a 4 plus, lead can be a 2 plus. Tin can be a 4 plus, tin can be a 2 plus. Chromium can be like a 3 or 2 plus, sometimes a 4 plus. Manganese can be like a 4 plus, a 3 plus, a 2 plus. Let's see, what other ones are there? Those, I think, are the big ones. Mercury can also have more than one charge, but I'm going to hold off on that. So, how do you know which charge to use? Well, then it'll be written in the name. So, if I say that there is lead, and then we use Roman numerals for oxide, it would mean that it's lead with a 4 plus charge, because that's what the Roman numeral tells me. Oxygen's a -2, and then I'd crisscross, a 2 goes there and a 4 goes there, right? When you crisscross. But what did I say? If you can reduce the subscripts, you should. And 2 goes into 4, so this would reduce to PbO2. Alright? If you had copper 2 chloride, then the Roman numeral 2 is telling me it's a +2 charge. Chlorine's a -1. I crisscross, 1 goes there, 2 goes there, so then my final answer would be that. Because I never write the subscript 1, and I erase my charges. Now how about going the other way? That can be a little bit more tricky. You have to do a little bit more thinking. So when I wrote the rules, when you write the charges, you have to watch out for the multi-charge elements. Okay? So if we had this formula, snow, so first you name the metal. The metal is tin. Can tin have more than one charge? Yes, it can. Tin can be a 4 plus, or tin can be a 2 plus. So then how do I know what charge it is? Basically, you have to reverse the crisscross. Oxygen's a -2, I have one of them. Tin, I have one of them. So in order to balance, tin would have to be a +2. So it's tin 2 oxide. How about this one? So name the metal, that's iron. Now, can iron be more than one charge? Yeah, it can be a 3 plus or a 2 plus. So then reverse the crisscross. So 3 would go up here, 2 would go up there, so it would be iron 3 oxide. Okay. Now I've been holding off talking about mercury. Mercury can be a +2, or mercury can be a +1. However, when mercury is a +1, it is always bonded to another mercury that's also a +1. Whereas when it's just mercury +2, it's a single atom of mercury +2. So you can have a single atom of mercury +2, however, when it's mercury 1, there's 2 of them bonded together. So what is the total charge then for that whole thing? The total charge is +2, and that's why mercury is confusing, because mercury 1 has a total charge of +2. Okay? So that's the confusing part. So some students find it just easier to memorize the answer than to think about it, but mercury 1 only exists when it's bonded to the halogens. So mercury 1 fluoride, mercury 1 chloride, mercury 1 bromide, and mercury 1 iodide. So mercury 1 only exists when it's bonded to fluorine, chlorine, bromine, and iodide. Why? We won't get into that, but these compounds are actually kind of important compounds, these mercury compounds. So you should be aware of mercury 1, but it only bonds with those 4. Mercury 2 can bond with anything. The formula is this. So only with mercury 1 do you not reduce. So you don't reduce mercury 1 compounds. Okay? So some people just find it easier to memorize the stuff in this box than to actually figure out what's going on. But if we were to try to figure out what's going on, it would be something like this. So mercury 1 fluoride what you'd say is, okay, mercury 1 means that there's a 1 plus charge, but I automatically have 2 of them. So that means my total charge is going to be a plus 2, because 1 times 2 is 2, so I have a total of a plus 2 charge. We kind of ignore all of that and say, okay, my total charge is what's important. And so then if I was pairing it with a fluorine, which is a minus 1, basically most of my crisscross is already done for me. So that's how it balances. And you might say, well, that's not really balanced. Well, it is if you draw it out. It's mercury 1. So there are 2 mercuries, each with a 1 plus charge. And there are 2 fluorines, each with a minus 1 charge. So if you add that all up, it equals 0, and that's the goal. Now, mercury 2 can still exist with something else, so it could be, like if we were to do this with mercury 2, mercury 2 just follows the rules normally. So you'd write the charge, and then crisscross, 1 would go there, 2 would go there. So mercury 2 just follows the rules. It's really mercury 1 that's a little bit tricky, and that's why students kind of find that it's easier just to memorize the mercury 1 compounds. Okay? Well, that's it for, oh yeah, and erase your charges, erase the number 1. So that's it for our second video, and our third video will be on polyatomics.